Do you know what time it is? It's test time. So let's buckle down, let's fly through this review. If you have any questions, you know how to get in touch with me. Otherwise, happy studying.
Thank you so much for joining me for our Unit 3 Graphing Linear Equations test review. Our first section starts out with standard form, which is ax plus by equals c. So what we're going to do is we're going to put each equation in standard form. For number 1, what we need to do is move the negative 5y term over to the left side of the equation. So the opposite of minus 5y is plus 5y. X plus 5y equals 0. That is in standard form. For our next equation, we're going to take the negative 2x term and move it to the front. And to move it over, we need to add 2x to both sides. 2x plus y, because the y was positive, equals 3, and that is in standard form. For number 3, I'm going to move the y term and the x term. I'm going to actually flip-flop them. So negative x plus y, because the y was positive, equals, well, let's move minus 1 over by adding 1. This is not the best way to write this answer. It's best to start out with our leading coefficient as a positive number. So a negative x means a negative 1 times x. So if I divide out the negative 1, x minus y equals negative 1. And literally it's just changing every sign to its opposite. For number 4, I'm going to come over to the side. I'm going to move my minus 2y term to the left by adding it to both sides, leaving nothing on the right, so equals 0. And this is not in standard form for 2 reasons. Number 1, the GCF of 10, 2, and 0 is not 1, so we can divide a number out, and I'm starting off with a negative. So I'm going to take care of both things at the same time. In my mind, I'm thinking, what will 2 and 10, what will divide into those two numbers? Well, a 2 will. If I want to also get rid of the negative in the front, I can divide out a negative 2. So when we simplify this answer, we're going to get 5x minus 1y, or just y, equals 0. For problem number 5, the x term is already on the left, but I'm going to move minus 2y over by adding 2y to each side. X plus 2y equals negative 2. And for our final example, the only thing we have to do is divide out a negative 1. We'll get y equals negative 2. So you can have a standard form equation without an x, so you just want to start with a positive y coefficient.
It may have been a little blurry, but if you still have questions, let me know. I can email you a copy of it, working it out on paper with a pencil. But standard form is ax plus by equals c. A, B, and C have to be integers, no fractions, no decimals, and their GCF should be 1. Remember, this test is multiple choice, so you should have a chance to at least guess, even if you're having just a little bit of trouble solving the equations.
The next 2 problems deal with graphing with intercepts, and y'all, this is so easy that even a caveman can do it. So for problem number 7, you see that on the x-axis I'm putting a dot at negative 5, and on the y-axis I put a dot at negative 2. Draw a line. They are 2 separate points. It's where the line intercepts or intersects the axes. For problem number 8, you're going to put a dot on the x-axis at 1 and on the y-axis at 4. Again, draw a line. Hey, just as a quick review, both of these lines have a negative slope. The next 2 problems are not as easy as 7 and 8. 9 and 10 are given in standard form. So what you need to do, or what the best way to work these problems, is to make a table of values. So I'm going to very quickly plug a 1 in for x. That means I can solve this equation for y. So I'll move the 1 over by subtracting it. And 0 minus 1 is negative 1. So when x is 1, y equals negative 1. That's an ordered pair, 1 comma negative 1. So my graph, I'll put a dot over 1, down 1. And now I'm going to find another point on this line, maybe plug a 2 in for x. So 2 plus y equals 0. To solve, I'm going to move the 2 over to the other side by subtracting it. And get y equals negative 2. That means when x is 2, y equals negative 2. And I'm going to go on my graph and I'm going to plot the point to -2. So you can plug in any values for x or any values for y and solve for the other coordinate. Another point would be the origin. So had you been looking for the x and y intercepts, it just happens to be 0 for both. That's why that's not the best method for this problem. And also, if I were to plug in a -1 for x and solve for y, I would get a +1. So I could also plot the point -1, +1. So for my next problem, you see that I have marked out the y term. That would be the same as plugging in a 0 for y. When you solve, you get x equals -15, but if you notice on your coordinate plane, there's not a -15. It only goes to -6. But I could plug a 0 in for x to find the y-intercept, which means I'll need to divide both sides by 5, and I get y equals -3. So that's a point, 0, -3, that I could plot. So now I just need to pick some more x values to plug in to solve for y. You can pick anything. I'm going to pick a -5 to plug in for x, and now I'm going to solve it for y. -5 plus 5y equals -15. I'm going to move the -5 term over by adding 5 to -15. I have 5y equals -10, and I'll divide both sides by 5, and I have y equals -2. So I can also use the point -5, -2 to graph my line. I'm going to plot both of these on my coordinate plane, and I'm going to draw the line. They have a negative slope. It's going down. It's yellow and timber. And I was smart to pick a multiple of 5 so that when I divide out, I didn't have a fraction. When you have an equation in standard form and you want to graph it, you would cover up the x term and solve it for y, or cover up the y term and solve it for x, and that would give you your x and your y intercepts. Usually that works. Sometimes you do end up with decimals or fractions. Sometimes it does go off your coordinate plane. If that happens, make a table of values. But on a multiple choice test with your equations, or your graphs listed, pick some points out from your graph and plug them in for x and y and see if they evaluate. Another way to sketch a graph is by using your calculator, and that would be if the equation is solved for y. So if I go to y equals in the top left-hand corner, and I type my equation in, -3 halves x minus 1. X is next to the green alpha key if you didn't see me press it in red. Press graph, and this is a picture of my graph. But more importantly, if I press second graph, the blue button in graph, this is going to give me a table of values. This is a list of points that are on the line. I can pick any of these points and plot them, or I can pick these points and look at the multiple choice questions to see if they're actually included on the equation of the line, and if they're not, that's not the correct answer. So some points would be 0, -1, 2, -4, and -2, 2. I can do the same thing for this next problem. I can go to y equals on my calculator. I can press second graph and pull up a list of values. A list of ordered pairs that I can plot. Some examples would be 0, -4, 4, -5, and -4, -3. We'll spend a lot more time next unit learning this, but I wanted to give you a sneak peek before this test. I'm going to use algebra, I know, shocker, to find the slope between these 2 points. y2 minus y1 over x2 minus x1. That will be a -1 over a -9, which will simplify to 1/9. Remember, every ordered pair is made up of an x and a y. The first point is called the x1 and the y1, and the second point, the x2 and the y2. So for number 14, I'll have 14 minus -16, 2 minus -13, because there's a minus sign in the formula for slope. That's going to give me a 30 over 15, and 30 over 15 reduces Remember, when finding slope, you can use the algebraic formula, the y2 minus y1 over x2 minus x1, or you can sketch a little graph on the side and count your rise over your run. But just remember, if it's going up from left to right, you have a positive slope. If it's going down from left to right, that's a negative slope. A line this way, horizontal, is zero slope, and a line up and down vertical is an undefined slope. Let me just leave the work up here for the next two. Negative 10 minus 11 over 3 minus negative 11 will give me a fraction that's going to reduce to negative 3 over 2 as my slope. And for number 16, 14 minus 20 over 14 minus 13 is a negative 6 over 1, which is negative 6. The next set of problems we get to is slope, which is just rise over run. Go up and over. Up 1 over 4. Rise 1, run 2. Rise 1, run 3. Number 20 is a little different because the line is decreasing from left to right. We're going to rise 7 and run 4, but because we're running into the direction towards negative infinity, that's going to be a slope of negative 7/4. Next, jumping to 21, another negative slope. You're going to rise 2, run 2. It's negative, so negative 2 divided by 2 is negative 1. And finally, rise 3, run 7.